Hello everyone. So in this video session we will discuss problem number 9, so related to projection of solids. The question is hexagonal prism 25 mm sides of base and 50 mm axis length rests on HP on one of its edges of the base. Draw the projections of the prism when the axis of the prism is inclined to HP at 45 degrees and appears to be inclined to VP at 40 degrees. This is the question that they have given. Okay, so in this question, so it is a solid problem, and what type of solid it is a prism. Okay, and what type of prism it is a hexagonal prism. So hexagon, if I say, it will be having 6 sides and the interior angle for hexagon will be equals to 120 degrees. Okay, and what are the dimensions of the hexagon? So the dimensions of the hexagon are, the base is 25 mm and the height is 50 mm. So this is the hexagonal prism that they have given the dimensions. So we will solve this problem in 3 positions. The first position is the normal position. So we need to identify in which plane the solid is resting and how it is resting on that particular plane. So if I just go through the question, he is clearly telling that it is resting on HP. The resting plane is horizontal plane. Okay, and how it is resting on this horizontal plane is, it is resting on one of its edges of the base. It means it is a side. So edge means side. So that what are the resting side that we will consider? So that should come towards my right hand side always. Okay, so in this particular position, if I see this particular hexagonal prism from the top, so it looks like a hexagon in the top view. So and if you see the front view of this particular hexagonal prism, it looks like a rectangle in the front view. Okay, and what are the edges, vertical edges that are visible are, so you can see all the 3 lateral edges. So but the axis line is not visible here. So why it is not visible? So I'll explain while doing the construction. So this is about the first position. So now first thing is, so we will take the XY line coming to the construction. So I have taken the XY line. So and with respect to this XY line, I have written VP and HP. So VP is above the XY line and HP is below the XY line, because we will always consider the first angle of projection. So in this particular VP and HP, so I need to draw the hexagon in HP because the lamina is resting on HP. So how to construct the hexagon, that we have discussed already in case of projection of planes. So in the same way I will proceed. So what I will do is, so since it is a side resting problem, I need to obtain side towards my right hand side. Okay, so what I will do is, I will take one point, I will choose one point on the XY line. So with respect to this point, what I will do is, so I will take 90 degrees. So I have taken 90 degrees with respect to this point. I have placed my scale, so protractor on that XY line, and I have marked 90 degrees. So with respect to this 90 degree point, I have taken one simple projection line. So extend the projection line. So this line must be very thin line. Okay, take the projection on with respect to that 90 degree point. So after obtaining this 90 degree point and after taking that vertical line, so what we need to is, what is the procedure that we have discussed in case of projection of planes is, so here the size of the hexagon, he has given it as 25 mm. The base size is 25 mm. So hence we need to take 25 mm with the help of the compass. So measure 25 mm with the help of the compass. So with respect to this center point, so you choose any one point on this vertical line what you have drawn already. So with respect to that point, you draw a thin circle like this. So you need to draw a circle of radius is 25 mm. So after obtaining this particular circle, what we need to do is, so already we will be having a line, vertical line. With respect to that line, I need to cut the arcs on either sides of that particular vertical line. So this acts as a diameter for us. So with respect to this point, consider the point on the circumference of the circle on that diameter, and you cut the arc on either sides of that diameter on the circumference of the circle. So you choose the another end point of the diameter. So with respect to this point, you cut the 2 arcs on the either sides of the diameter on the circumference of the circle. So in this way, so if we cut 4 arcs totally, so and these 2 end points of the diameter also act as a end point of the hexagon. So in this way we will get the 6 corners of the hexagon. So once after obtaining the 6 corners, so you need to join them with the help of dark line. So this is one edge. So this is my second edge. So let us complete this portion. by drawing the dark lines. These lines has to be dark lines. Okay, so this is fourth one, this is fifth edge. So this, all these edges has to be dark. So finally the sixth edge, this is the sixth edge, what I'll get here. So this line has to be dark line. So once after obtaining the 6 edges, so what we need to do is, so we need to identify the center point of this cross section. So we are having the cross section as hexagon, so we need to identify the center point. So how to identify the center point here is, so it is very easy in case of hexagon. So we need to draw two diagonals. So already one diagonal is there, so that is the diameter of the circle, so, and you draw one more diagonal. Otherwise the point from which you have drawn the circle, so that itself is the center point of the cross section. So this is your center point. So through this center point you will be having the axis passing inside the solid. Okay, this is about the top view. So these diagonals has to be very thin lines. So if you see the object from the top, only these 6 edges are visible. So you will not be having these diagonals. So that is for our construction purpose. In order to obtain the center point, so we have taken the diagonals. That's it. Okay. So now I'll do the dimensioning. So take the extension line with respect to one edge and you draw dimension line, and with respect to this dimension you write the value as 25. Okay. So after doing this much, what you need to do is, so I'll go with the namings. So how to do the namings is, so I'll take this right side, the resting side, as A of A1. So we know that all, in case of solids, so all the base corner of that prism the base corners will call it as the namings with subscript 1 or suffix 1. So all the base corners are not visible, so they are there with the namings 1. So hence I'll write it as A of A1. So A is the top corner and A1 is the base corner. So likewise we will be having B of B1. So here we will be having C of C1. This point is D of D1. So E of E1, and finally we will be having F of F1. So here, since it is a hexagon, we will be having the 6 corners. So this is about your top view. So now I will take the projection in order to obtain the front view. So take the projections from each and every corner. So take one line, vertical line, first line. So if I take the projection from this C of C1, so that also passes through this center point of the hexagon as well as F of F1. So finally you will be taking the third projection line. So that is B of B1, and it also passes through A of A1. So in this way we need to take the projection. So after taking the projections, so we need to take the height of the prism. So what is the height? So height of the prism is 50 mm. Okay, and in the front view, so this hexagonal prism looks like a rectangle. So that is what we know, because it is a prism. So some of you, what you do is you'll write, in case of exam, when the question is related to prism, you will draw it as a triangle here, so which becomes your pyramid. So that should not happen. So we know that, we came to know that from the question, the height of the prism is 50 mm. So now with respect to this projection points, you take 50 mm point. Okay, so likewise you extend this projection line, the extreme projection line, third line, so to a distance of 50 mm. So in this way. So now I have got the 4 boundary corners of the rectangle. So you join all of them with the help of dark lines. So this is one line, this is the second line, so that is top face and the base, and these are the lateral edges. So this is the boundary what I am having here. So this is the another lateral edge. Okay, so some of you will get the doubt that, so whether I should draw this line as axis line or continuous line. So here I have forgot this naming. So that is the center point, axis point, that is O of O1. So if I observe this second projection line, so the center line, so here we are having the axis point. So exactly below this axis point we are having the corner of the hexagon. It means that C1 is the lateral edge. It will be, the edge will be like this. So this point will be C1 and this point will be C. Okay, and behind this you will be having the axis point like this, and behind that you will be having F of F1. If I see the object from the front, if I see this object from the front, I can see this first lateral edge, but I cannot see this O of O1 edge, that is axis, and this edge also, F of F1. So F1 edge is also not visible to you. So since this is the edge, that is the lateral edge of the prism, so this line should become a continuous line. if suppose, so we don't have any corner exactly below the center point of that hexagon, so it would be it would remain as the axis line itself. Here in this case we are having the point, so this line will become a continuous line. So this should not be an axis like this. Okay, so in this way we can see the three lateral edges. So that is about the front view. What is the height of the prism? So height of the prism is how much? 50. So here the axis length is 50. So I have taken it as 50 itself. So this is the axis length what I am having. I'll go with the namings now. So how to do the namings? So first you consider the base corners. Base corners are the corners with suffix 1. So if I consider this line at the base, so we are having two namings, that is B1 and A1. Among these two corners, so which is the corner nearest to the XY line? A1. So you place that A1 inside the brackets. So I should write this as B1 dash of A1 dash. So likewise we will be having C1, O1 and F1 on the same single line. So among these three corners, so which corner is away from the XY line, that corner you place it outside the bracket. So C1 dash of O1 dash of F1 dash. So next finally you will be having D1 and E1. So I should write D1 dash of E1 dash because E1 is nearer to the XY line. So this is about the base corners. You copy the same namings above without suffix 1. So then you'll get the top face corners. B dash of A dash. So here I'll get it as C dash of O dash of F dash. So here I'll be having D dash of E dash. So this completes the first position. So top view it looks like a hexagon and front view it looks like a rectangle, and three lateral edges are visible and axis line is not visible here. Okay, after doing this much, you erase all the extra projections, that is the circle and what are the lines that you have taken it extra, so you erase them. Don't keep any extra lines here. Okay, after doing this much, so I need to go to the second position. In order to go to the second position, I need to see in which plane I have considered this prism. So I have considered the hexagonal prism on HP. So if I go to the second position, I need to take the inclination with respect to the same plane. Which plane is that? HP. Okay, so let us see what is the condition. So second position is condition with respect to HP. Why we need to take condition with respect to HP? Because we have placed the solid on HP, hence you take the condition with respect to HP. What is the condition with respect to HP? In the question he has given that the axis of the prism is inclined to HP at 45 degrees. What is the angle of inclination? 45 degrees he has given. Okay, so now, so what is making an angle of 45 degrees? The axis of the prism OO1 makes an angle of 45 degrees with respect to HP. So what are the front view that is there? Okay, in the first position, so you are having the axis it remains as vertical, okay, with respect to HP. If I go to the second position, I need to tilt this rectangle in such a way that this axis should make an angle of how much? 45 degrees. If this axis makes an angle of 45 degrees, automatically this other two lateral edges what you are having, so those also makes an angle of 45 degrees because so these three edges are parallel to each other. So now I'll consider how to redraw this is I need to tilt this rectangle to in such a way that this entire rectangle is tilted to an angle of 45 degrees. Okay, so how to do that? Let us see. So now I have taken this as my resting side, that is B1 dash of A1 dash. So this point should act as the reference point. So that point should remain on the XY line in all the three positions. So I'll choose any one point on the XY line in order to construct the second position front view. You choose any one point, you choose this point appropriately. Okay, so you need to adjust your space, so take the point carefully. So this point, what are the reference point that you have taken? So that will be a resting point, that is B1 dash of A1 dash. So with respect to this point, I need to take the angles. So what is the angle of inclination that he has given? So 45 degrees. So place your protractor at that point along your XY line. So and you mark the angle as 45 degrees. So I need to take the angle as 45 degrees. I have taken one point. So with respect to this point, I'll take the projection line. Thin line you extend. The line should pass through this reference point and this 90 degree point. Like this you extend. Okay. So after doing this much, so we know that, so I have got one reference point here. So what I said in the first position, what is the first position that we are having? The same position figure, I need to tilt to an angle of 45 degrees. It means that the dimensions will remain same. So what on this 45 degree line I need to obtain the another corner of this lateral edge. What is that? B dash of A dash. So what is the distance from this B1 dash of A1 dash to B dash of A dash? So that will be your height of the rectangle. So take the distance from B1 dash of A1 dash to B dash of A dash. So place at B1 dash of A1 dash and you cut the arc and see where it touches, where it intersects that projection line that you have taken. The point where it intersects, that will become your B dash of A dash point. So once after getting these two corners, I can obtain all the remaining corners. First I'll go with the boundary corners, that is this lateral edge I need to obtain. So what is that? D dash of E dash to D1 dash of E1 dash. If I observe this lateral edge, these two are parallel, but if I consider this base, so top base and top face, so they are perpendicular with respect to this particular lateral edge. Okay, so hence what I'll do is I'll take the protractor. So I'll place the protractor on this 45 degree line and I'll mark 190 degree point. So place it properly. Once after obtaining these two corners, so I'll take the another two boundary corners. How to take is you place your protractor along that 45 degree line at point B1 dash of A1 dash and you mark 190 degree point. Okay, place it properly and you mark the 90 degree point here. Again similarly, so you place your protractor at B dash of A dash and you mark one more 90 degree point here. So with respect to these 2 points, so you draw thin lines passing through that 90 degree point as well as that B1 dash of A1 dash. Similarly, you draw one more line, so that is with respect to the another 90 degree point. Okay, once after taking these two 90 degree lines, so what you need to do is, so I need to obtain the another two boundary corners. So which is that? So from point B1 dash of A1 dash to D1 dash of E1 dash, take this distance. So place at B1 dash of A1 dash and you cut the arc on this 90 degree line. So with the same dimensions, it will be the same above. So with the same dimension, place at B dash of A dash and you cut the another arc. And see where those two lines, those 2 points you'll get. So those points you name it as D1 dash of E1 dash and this point will be D dash of E dash. So likewise, so similarly, so you take the distance from B1 dash of A1 dash to C1 dash of O1 dash of F1 dash and you cut the arc on that line. So likewise you cut with the same distance, you cut the another arc on that above line. So in this way I'll obtain this intermediate points, that is C dash of O dash of F dash, and finally I am having here it as C1 dash of O1 dash of F1 dash. So you join all these edges with the help of dark lines. So now I'll get the rectangle. I'm redrawing this rectangle as it is, so in such a way that the rectangle will get tilted to an angle of 45 degrees. So this edge has to be dark, so let me draw that at last. Okay, so when you extend the lines from this intermediate point, so you extend in such a way that the line should be a continuous line, so within this rectangle. So when you take the projection outside, so that line should be an axis line, because the second line I'll be extending. Okay, so I need to extend the axis line here and I need to write the angle of inclination is how much? So 45 degrees. So this is how we need to obtain the top view. So front view. So how to obtain the top view is, so we need to take the projections from each and every corner. You take all the horizontal projections as well as all the vertical projections. So here I have taken the projections, vertical projections as well as horizontal projections, and I have done the namings according to the lines, so where those lines will intersect. Okay, so in that way, so around that point O1 I have got the base corners, around the top corner axis point O I have got the top face corners of the prism. So now how to do this top view is, So after taking the projections and doing the namings, so my next step is I need to draw all the boundary lines. So always all the boundary lines has to be the dark lines. So how to identify the boundary lines is, so you place the scale between any two corners. So whether I should consider these two corners or not, so what we need to do, how to take, whether it is correct or not. So with respect to this figure, so that is the naming figure is here. Since it is a hexagonal prism, so I need to have the 6 corners. So from each corner you will be having the three edges passing through it. So from each corner you will be having the 3 bonds. Okay. So in the same way, so I have taken first edge is D1 and C1. I can place my scale between D1 and C1. So because I will be having connection from D1 and C1. So we will be having the edge. So and this edge will be my boundary edge, because so why it is a boundary edge is, so if I place the scale between these two corners, okay, and if I draw a line, so I am getting all the remaining corners on the same side of the scale. So if I am getting all the remaining corners on the same side of the scale, so that will be my boundary edge. So in that manner, so I need to draw all the boundary lines. So though if I join all the boundary lines, so it forms a closed loop. So like with that keeping in our mind, so I am doing all the boundary lines as thick continuous lines. I will be having the lines like this. So that is A to F, F to F1, that is also a boundary edge. Sorry. So next is E to F1, and finally D1 to E1. So I have got all the boundary edges as thick continuous lines. So after doing the boundary edges, what we need to do is we need to identify the hidden corners. Which are the hidden corners here is in this figure. So if I see this object from the top, so the corners nearer to the XY line, they are invisible. So which are those nearest corners? A1 and B1. Both these corners I need to place it inside the bracket. So they will be the hidden corners. Okay. So from this hidden corner you will be having the dotted lines. So how many lines will be there from each corner, you can observe here. So if I consider this A1, so A1 is my hidden corner. So with respect to this corner A1, I will be having 3 edges passing through that point. So all these 3 edges has to be dotted. So if they are coming inside the boundary. Okay. So right now I don't have the single edge starting from A1. So I need to draw all the 3 edges passing from A1 as the dotted lines. So which are those edges? So first is A1 to F1. So A1 to F1 is your dotted line. You need to draw it as dotted like this. So next is A1 to A. So A1 to A is here. So you need to draw this line as dotted line. So A1 to A has to be dotted. That should be drawn as thick dashes line. So next is A1 to B1. So A1 to B1 has to be dark. So it is again a hidden line. So that should be drawn as dark dashes line. So I have drawn the 3 edges passing with respect to this point A1. So that completes the work. So next I'll go with the point, another hidden corner, that is B1. So I'll consider this point now. Again with respect to point B1, I must have 3 edges passing through with respect to that point. So which are those 3 edges? B1 to A1, B1 to C1 and B1 to B. So among these 3 edges, already one edge is drawn as thick dotted line. So I should draw the remaining 2 edges as dotted line. So which are those? That is B1 to B. So this has to be dashes thick. So next is B1 to C1. So this is the another hidden edge. So in this way I need to draw the dotted lines with respect to the point that is the hidden corner. So now what I need to do is, next step is I need to check each and every corner for 3 lines. So if I just look at this figure deeply, so the point D, with respect to this point D, so I don't have a single line passing with respect to this point. Okay, so according to this figure, so we must have 3 edges passing through this from each and every corner. So here, since it is not my hidden corner, the edges passing through this particular point will not be hidden. So they must be drawn as thick continuous lines. So with respect to this point D, which are those 3 lines? So first line is D to C. So this should be drawn as thick continuous line. Next is D to D1. So this should be drawn as thick continuous line. D to E. So this is the 3rd edge with respect to point D. Okay. Similarly, with respect to point E, again we must have 3 lines. So only one line is there, that is starting from E. So that which is that edge? ED. So this edge you must not consider. This dotted line is starting from A1, not from E. Okay, only one edge is there. So which are those three? So those two missing edges, that is E1 to E. So this should be drawn as thick continuous line. So this should be drawn as dark continuous line. So finally I will be having the third edge with respect to this point E. So that is E to F. So this must be drawn as thick continuous line. So why I am drawing the as thick continuous line is because this is not my hidden corner, D and E. So if I check each and every corner now, I will be having three edges, so that satisfies the condition. So now this line is missing, so you draw this line as the axis line itself, like this. Okay, so this completes the second position top view. So now I will go with the third position. So condition with respect to HP is over. So I will take the third position now. So what is that condition with respect to VP? So when I just read this question, so what is inclined to VP? Angle of inclination is 40 degrees with respect to VP. But what is this? What is inclined to an angle of 40 degrees with respect to VP is the axis of the prism. So, okay, appears to be inclined. So he is talking about the word appears. So which is that appearing axis? So if I just see this figure, so this is the true axis. This is your true axis. And where you will get the appearing axis? This itself is your appearing axis. So this is your appearing axis. So what is telling in the question is, so you incline this appearing axis to an angle of 40 degrees with respect to VP. So we need to redraw this shadow itself, this figure itself in the third position. Redraw this figure, this second position top view figure in the third position top view. So, and he is also telling about the same figure. So he is telling us that, so you incline this appearing axis to an angle of 45 degrees. So there is no question of taking the beta angle here. So directly you can place this O1 point on this 40 degree line. Okay, so angle of inclination. So what I have done is I have chosen one point here. So I am taking it from right side because the axis is inclined. That will be easy for me in order to reconstruct. So hence I am taking like this. I have considered one point. So with respect to this point, by making use of the protractor, I have taken the 40 degree line. Okay. So next is what I need to do is I need to obtain this axis point, that is O1 point on that 40 degree line. So directly I need to place this axis points. So place O1. So I have chosen one point and I have cut the arc. So with respect to these 2 points, I will do the naming. So this point will be O and the other point will be O1. So now I need, with respect to these 2 corners, I need to obtain all the remaining corners of the hexagonal prism. Okay. So now how to obtain all those remaining corners is, you just observe here. So in this figure, so we'll be having the vertical edges. So when I consider all these vertical edges, 1, 2, 3, 4, 5 and 6. So I'm having the namings only for O1 as well as O. Okay. So I need to do the namings for all the points. So at this axis intersection point. So this point I call it as 1. So here I am having the naming already O1. So this point will be 2. So the other point will be 3. So this is 2 and 3. So this line intersection point is 2 I have done. So this point intersection is 3. So here I am having O point. So I will extend this projection line. So and I call this point as 4. Why I am considering these lines, these points is because, so I am having this O1 point already that is lying on 40 degree line. Okay. So I need to obtain all these edges, all the remaining corners. So if I observe D1 and E1 are there on same single line. So this line is passing, this line is perpendicular with respect to this O1 at some point. So that point I call it as 1. See, likewise I will be having F1 and C1 above and below this O1. So this A1 and B1 is there with respect to point 2. 3 with respect to point 3 we are having E and D. With respect to O I am having FC, and with respect to point 4 I am having AB. I need to obtain all the lines. So all these vertical lines I will take. So what I do now is, so by making use of the protractor, so take the dimensions now first. I need to obtain all these points 1, 2, 3, 4. Take the dimensions from O to 1. So place at O1 and if cut the arc. So take the distance with respect to one point itself. So take the distance from O1 to 2. It will be same almost. So take the distance from O1 to 2. Place at O1 and if cut the arc. This point is 2. Okay. So I have got point 1 here and point 2 here. So if you take the distances from O1 to 3, place at O1 and you cut the arc, you will get the point 3. So next O1 to O point is there. So last point is O1 to 4. Take the distance from O1 to 4 point, place at O1 and you cut the arc to obtain which point? So this point I call it as 4. Once after obtaining this 1, 2, 3, 4 point and O1, so with respect to these points I will obtain 90-degree lines because I need these perpendicular lines now. Okay. So by making use of the protractor, you place your protractor at point 1 along this 40-degree line and you obtain the 90-degree point. Likewise, you obtain all the perpendicular lines. So after taking all the 90-degree lines, so with respect to these points 1, 2, 3, 4 as well as O and O1, so I'll take the distances now from 1 to E1. Okay, so this distance will be same from 1 to E1 as well as from 1 to D1 also, and it will be same from 2 to A1 and 2 to B1. So likewise it will be same with respect to this point ED as well as AB with respect to point 3, 4 respectively. Okay, so with the same distances, so I'll cut the arc. So by taking the points above, I'll cut the arcs above and below that 90-degree lines. So likewise I'll cut the arcs for all the points. Okay, so similarly take the distance from O1 to F. So I have taken the distance from O1 to F. So you cut the arc above as well as below. Okay, so once after cutting the arcs, you do the namings. So after doing the namings, so you join all the corners. So as you're having the lines in the second position top view, so the figure has to be same from the second position top view and the third position top view. So it must be same. So if I'm having the boundary lines, continuous lines, so you draw them as continuous lines. If you are having it as the dotted lines in the second figure, you draw it as dotted lines itself. Okay, so if I follow the same procedure what I have done in the second position top view, first I will do all the boundary lines as thick continuous lines. So C1, if I join all these boundary lines, so they will be forming a closed loop. So AB is my boundary edge. Next is A to F, so this is the boundary edge. So F to F1, so F to F1 and finally F1 to A1. So it forms a closed loop like this. So now with respect to this hidden corners, that is A1 and B1, so with respect to this point A1 I will be having 3 dotted lines. So you draw the 3 dotted lines now that is passing with respect to this point A1. Okay, so A1 to A is the second dotted line. Next A1 to B1, so this is the third dotted line starting with respect to point A1. Now